The first part of this video is going to tackle the third law of exponents, which is the exponent of zero. So you know that I always say that mathematics is just a study of patterns. So we're going to use patterns to figure this out. If I were to ask you to fill in this block right here of this table, 2 to the 0 power, before starting this video, you're very likely to think that that's 0. I mean, that kind of makes sense. But let's make sure. Let's investigate. Okay, so we're going to do this table based on what we already know. 2 to the 5th power we know is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. Okay? 2 to the 4th power would be 2 times 2 times 2 times 2, which is 16. And then 2 to the 3rd power is 8, 2 squared is 4, 2 to the 1st power is 2. And before you get all zero happy thinking you're going to put 0 here, let's stop because we're not totally sure. We've never really worked with a 0 exponent before. And let's look at the pattern here. If we're going from 32 down to 16, and from 16 down to 8, from 8 down to 4, and 4 down to 2, what's happening each time? We're getting smaller, and so we are dividing by 2. So you can turn your paper sideways and put in divided by 2. So we just need to continue that pattern. 2 divided by 2 isn't 0. 2 divided by 2 is 1. So, against probably our human instinct, looks like 2 to the 0 power is 1. Let's see what happens when we have a negative base. Okay, so negative 3, I'm going to actually write this, well, I can do it here. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3. Okay, the easiest way to do this is to think, well, these two make positive 9, and these two make positive 9, so 9 times 9 is 81, and then 81 times a negative 3 is negative 243. Negative 3 to the 4th power would be this positive 9 here, this positive 9 here. That is a positive 81. Negative 3 to the 3rd power would be a negative 27. Negative 3 to the 2nd power would be a positive 9. And you probably can tell that there's a pattern going on here with our negative signs, right? It's every other one winds up being a negative. So this would be a negative 3. And again, we're not sure what this is. So let's look at the pattern. What are we doing every time in this column? We are dividing again by negative 3, whatever the base is. So if you continue that pattern, negative 3 divided by negative 3, remember your integer fox, a negative divided by a negative is a positive, and a negative 3 divided by negative 3 is going to be 1. So we have just proven with patterns that no matter what base you start with, whether it's positive or negative, when we get to the 0 power, it's 1. Now, let's prove it a different way. Let's use our division rules for exponents. We're going to be division detectives, okay? So we've got, sorry, I'm scrolling, 4 to the 3rd power over 4 to the 3rd power. Well, if we write that out, it'd be 4 times 4 times 4 on the top and 4 times 4 times 4 on the bottom. And then we know that we can cancel out some things, right? This one and this one cancel out, this one and this one, this one and this one. And so all that we're left with is 1. Well, what does that have to do with our division rule? We remember that whenever we're dividing with exponents, we wind up subtracting them. So if I take 3 and I subtract 3, what do I get? I get an exponent of 0. So 4 cubed divided by 4 cubed is the same thing as 1. And 4 cubed divided by 4 cubed is the same thing as 4 to the 0 power. So it follows that these two are the same thing. 4 to the 0 power is 1. So that is law number 3. Any term raised to the 0 power is 1. Well, now we're going to continue on to our 4th law. We have 5 total, but today we're just going to do one more. And that is what happens when you have negative exponents. Okay, so I'm going to scroll down a little bit more so I can get this whole table in here. We're going to pick up where we left off. So this is just kind of an extension of our earlier table. So we know, we've learned that 2 to the 0 power is 1. And remember, our pattern is that we are dividing by 2. So we are going to divide 1 divided by 2. Well, what does that look like to you? To me, it looks like a fraction. So 1 divided by 2, of course, is the same thing as 1/2. What if we do this and we divide it by 2 again? Well, 1/2 divided by 2, we would keep, we would change, and we would flip. Remember, this is 2 over 1. And we get 1 on the top, 2 times 2, 4 on the bottom. So in this case, we have 1/4. If we divide by 2 again, we're going to get 1/8. And 2 to the negative 4th would be 1/16. Now, I want you to kind of look back to our earlier table. Let me scroll up here and see if we can make a prediction. All right, remember, we had 2 to the 4th power, and it was 16. And now we have 2 to the negative 4th power, and it's not negative 16. It's actually 1/16. So doesn't it look like to you that every time that power is actually going to the bottom of a fraction? So it would follow that 2 to the 5th power is 32. So 2 to the negative 5th power is going to be 1/32. Same thing here. Negative 3 to the 0 power we know is 1. And remember, we are dividing each one by negative 3. Well, 1 divided by negative 3 looks like that, but of course, we really prefer to put the negative on top. It doesn't really matter where you put it, but usually we put it on the top because we don't want to forget that it's there. If we divide this by negative 3, so negative 1/3 divided by negative 3 would be negative 1/3 times, so keep, change, flip. I'm going to put the negative on the top. And a negative 1 times a negative 1 is positive 1, and 3 times 3 is 9. So that gives us 1/9. So you can probably figure out what the next one's going to be. It's whatever negative 3 to the 3rd power was, which remember, is negative 27, and it's going to go down to the bottom. And then I'm going to put the negative on the top. So this one normally would be positive 81. It's going to go down to the bottom, and it's 1/81. And then this one would be negative 1/243. So what negative exponents do is they don't make the number into a negative. They make it into a fraction. So on the flip side of your paper, that's the first blank. Negative exponents turn integers into fractions. Now there's something else that we can think about. So let's kind of approach it from the division perspective again. 2 squared is 2 times 2, which is 4. So if we evaluate that, that's 4. And 2 to the negative 3rd power, we just learned 2 to the 3rd power is 8. And if it's a negative exponent, it would be 1/8. So really what we're doing is we're taking 4 and dividing it by 1/8. So if we keep, change, and then flip, this winds up being 4 times 8 over 1. 4 times 8 is 32. Okay? Well, let's think about what if we subtracted these exponents. Since we are dividing, we would subtract the top number minus the bottom number. We would need to leave change opposite, and we get that that is 2 to the 5th power, which of course 2 to the 5th power is 32. So let's kind of look and see. Let me change my color for a second just so I can really point this out. What's really happening is we are taking this negative exponent that's on the bottom and we are moving it up to the top. So instead of just 2 squared, we're going to have it also times 2 to the 3rd power. And 2 to the 2nd times 2 to the 3rd is 2 to the 5th. So whenever you have negative exponents, you can think of them this way. They always want to go where they're not. This dude here was on the bottom. He wanted to go to the top. Now, if you kind of look here at this -3 dude, he wanted to go down to the bottom. Or better yet, it's probably better just to kind of look up here again just to remind ourselves that every time we had a negative exponent, in this case it wanted to go down to the bottom. And in this one here, we saw that it wanted to go to the top. So where do negative exponents want to go? Wherever they are not. So on the flip side of your notes, you're going to want to say that they always want to move. Negative exponents are like negative people. They complain all the time. And wherever they are right now, they don't want to be. They want to move. So you move them either from the top to the bottom or the bottom to the top, and then they're happy and they've got a positive exponent. All right, those are the 2 laws of exponents that we are talking about today.